So we've looked at the theory behind parametric equations. What I've got here for you is a video with a couple of questions. I want you to read the questions, pause the video, have a crack at them, and then come back and check your answer against the stuff I'm going to present here. So here you go. Just two quick simple questions for you. I want you to find the Cartesian form, i.e. the constraint equations, for each pair of parametric equations below. So pause the video and have a crack at them. So the first question, I had to get the constraint equation for these two here when I had x equals 6t squared and y equals t cubed. Now remember, when we were doing these, what we did was we took the x equation, wrote it and changed the subject of the formula to t, and then substituted it back into y. So if we start with that, we've got x equals 6t squared. So in order to change t to being the subject of the formula, we get t squared is equal to x over 6. So t equals the square root of x over 6. So there you go, I've got t when I've written it in terms of x. What I do now is I substitute that back into the y equation. So for that, that would be y equals square root of x over 6 cubed. If I was to write this in terms of powers, I'd know that the square root of x over 6, it can be written as x to the power of a half. So what I'd then be able to say is that y equals x over 6 to the power of 3 over 2. So there you go. That's my constraint equation for that pair of parametric equations. Second set of equations was given by this, and again it's the same set of steps. All I have to do is write the x in terms of t, then substitute it into the y, and I've got my answer there. So what I'm going to do, if I got x equals t, well, I've already got it written in terms of t, which is quite nice, so I just substitute it directly in. So I end up getting that y equals the square root of 1 minus x squared. Now that looks like it could be quite a straightforward equation, but what I can do is if I square both sides there, I'll end up getting y squared equals 1 minus x squared, and I then take the x squared across, I've got x squared plus y squared equals 1. Now that there is the equivalent of representing a circle with a radius of 1 and centre at the origin. So if I was to draw it on a diagram, there would be my centre of my circle. It would look like that, and my radius, which is there, r would equal 1. So that there's the constraint equation for that example there. So sometimes it can be quite nice and straightforward. Always try and rearrange it though, so that it's in a format that you can work with and that we're able to identify. So sometimes, like the previous example, it can be left the way it is. Other times, with a wee bit of rejigging, we can actually write it in a format where we can say, this is what it represents, and this is how we can see it.